So yesterday we focused on vertical angles, and today we're going to continue looking at how to find missing angles in a diagram, especially if there is more than one missing angle. So let's go ahead and look at this problem below. Four rays meet at a common endpoint. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x, and then find the measurement of angle BAC and angle DAE. Okay, so again, we're given this diagram, so what do we need to first do? Well, let's look at the different angles we see within it. So the first thing is that they are telling us angle angle BAC is one of the missing angles, so I'm going to highlight that yellow, and angle DAE is the other missing angle, so I'm going to highlight that blue. Go ahead and draw this in your notebook. I also see that we have angle BAE, which is 204 degrees. And I also see this angle CAD has our right angle symbol, which means this one is a what? It's a 90-degree angle. So let's go ahead and label that as well. So now that we've identified the important angles, what strategy can I use to start solving for these missing angles? Well, normally I look for straight lines to find angles that add up to 180 degrees. However, I don't see a straight line with several angles on top of it, but I do see that all these angles come together at this point. So let me go ahead and color this in. They come together at this point. And I know that angles add up to a very special number. And if I look back and I start angle C, and I draw my pencil all the way around to go back to angle C, I know that all these angles at a point have to add up to 360 degrees. So go ahead and write this down. Whenever we see angles that come together at one point, we know they all have to add up to 360 degrees, like a 360-degree turn. Okay, well that can help me start writing my equation because I now know that x plus 204 plus 5x plus 90 have to equal up to 360 degrees. Now that we have our equation, how can we start solving it? Well, I do see some like terms here, so I'm going to go ahead and identify the things that are alike with my circles and boxes so that I can begin combining what I see on the left side. So I see x plus 5x, which will give me a total of 6x's, 1x plus another 5, 6x. And I also see 204 plus 90. So when I add that up, I get 294, and they still equal 360 degrees. So I have combined my x's together, and I've combined the angles that I know about together so that I can get a simplified left side. So if the two angles equal 294, how can I figure out what the rest would have to add up to? Well, I can subtract using my inverse operations to see what angle is left over. So 6x equals 66 degrees. Great. So that means 6 times x equals 66 degrees. So again, using my inverse operations, I need to divide by 6, and I know that equals 11 degrees. So x equals 11 degrees. Well, what angle was that again? That was angle BAC. So that is 11 degrees. I could put that in my diagram. So I'm done with one of them. But now I need to find angle DAE. Well, angle DAE says that it's 5x. So how do we find that value? Well, I know that it means to multiply x by 5. So we're going to multiply 11 times 5. So if I substitute, which is 55 degrees. So this angle equals 55 degrees. And what angle was it again? It was angle DAE. So to stamp, we can use angle relationships to write equations to solve for missing angles. Angles at a point add up to 360 degrees. Angles on a line add up to 180 degrees, and an angle with a square at the corner is a right or 90-degree angle. Let's try some more independently.